Okay, so this video here is just extra practice problems if you feel like you need them for graphing. In particular, we're going to be doing practice for petal graphs first, and then cardioids, and then limasones. So you can kind of forward to whatever section it is that you think that you need practice on. So let's go ahead and start with petals. So for the first one that I'm going to do, so I'm going to graph R is equal to 6 sine of 2 theta. So I would know this is a petal graph because there's no adding or subtracting. So so first press pause, try to do it yourself, and then check the solution afterwards. So you should always do that for every single problem. So try to graph this one first, and then once you have that, then fast forward and see if you have the same graph as I do. Okay, so I always want to figure out, location of my first petal. So that's going to be the first thing I do. Where is the first petal located? So in order to do that, I always take that coefficient of the trig function, and I'm going to replace r with that, right? Because that's the length of my first petal, and I want to know where is that first petal located, and that would be when you have your equation 6 sine 2 theta equal to 6, right? That's the first time it reaches that tip of the first petal, and so then I would just solve that equation. So I would divide both sides by 6. And then I want to know where sine is equal to 1, so I would look at my unit circle and I would say, okay, where is the y value equal to 1? And that is at pi over 2. So then this would be 2 theta is equal to pi over 2, right? And that's because that's where sine is equal to 1. And then from there, I could either divide by 2 or multiply by a half. And I'm going to multiply by a half because I have that fraction of pi over 2 already. So then I would have theta is equal to pi over 4. So then that means my first petal was a radius of 6, and it occurred at pi over 4. And so that's where my first petal is going to be located. And so then the next thing I'm going to do is go ahead and do that graph. So I'm not going to do it on graph paper because I want to show you like how can you do that otherwise. So we don't always have kind of that perfect graph paper. So I don't need to do concentric circles. I just need to mark different things. So this would be kind of my axes here that I would start with. And then I'm going to go to where I have pi over 4. And so that is kind of in the middle of quadrant 1. So we're going to call this pi over 4. And then I have a radius of 6. So instead of drawing circles, I'm just going to count out pi over 4 out 6 units. And then I'm going to put my dot. So if I didn't have the concentric circle, graph paper, then that's how I would do that. And then I would create that teardrop. And there's the first petal. And then from there, I want to find the spacing and the number of petals. So to do that, where I have to look is I have to look at what am I multiplying theta by, and that is my b value, right? So then for my spacing, I know that b is equal to 2, which is an even number. So then I'm going to double that, so 2 times 2, so that would give me 4 petals. And they have to be evenly spaced, all 4 of them, between 0 and 2 pi. So then that would be 2 pi divided by the number of petals I'm going to draw out, which is 4. And normally I would reduce that, right? So I would use pi over 2. But because I have already that denominator of 4, right? So this is a denominator of 4 here. Then I want to go ahead and keep this as a denominator of 4 because I'm looking to have that common denominator. So then for my spacing, that means I'm going to add 2 pi over 4 to each of these, or to each petal, right, that I draw, and that's how far apart I would be. So I'm going to go ahead and have this mark out as my common denominator as well. So that would be 4 pi over 4 2 pi over 4, and 6 pi over 4. So I'm going to add 2 pi over 4 to 1 pi over 4, which would put me at 3 pi over 4, which is in the middle of quadrant 2. And then again, I'm not going to draw my concentric circles. I'm just going to count out 6 because that's how far out my petal goes. And then I would have my next petal. And that would be at 3 pi over 4. And then I'm going to add another 4 pi over 4, or excuse me, add another 2 pi over 4 to 3 pi over 4. So that would put me at 5 pi over 4. So again, all I'm doing is taking 3 pi over 4, and I'm adding my spacing, which was 2 pi over 4. And so that gave me my 5 pi over 4. And then I'm going to just count out 6 units along that line, the radial line, instead of making concentric circles, right? And that's just a way to kind of get around if you don't have polar graph paper. And then one more to do, so I'm going to add 5 pi over 4, and I'm going to take that and add my spacing value, which was 2 pi over 4. And that would be 5 pi plus 2 pi would put me here at 7 pi over 4. And then count out 6 units. Okay, so then I also have to do my start and my stop. So in order for me to do that, that would be when theta is equal to 0. So because this turned out to be theta equals pi over 4, that's not really my start and my stop, right? So it's going to occur when theta is equal to 0. So I'm going to take that original equation I started with, and I'm going to replace theta with 0 and solve that. So that would be 2 times 0 is 0. And then I know that sine of 0 is 0, and so 6 times 0 is 0. So then that would be at the pole. So my start and stop would be at the pole, and I would be going towards pi over 4 in a counterclockwise direction, right? So always in a counterclockwise direction, and then in this case at 0. Okay. All right, let's go ahead and do another one. So we're going to do r is equal to 5 and then cosine of 3 theta. Okay, so I know I have a petal graph because there's no addition, subtraction. So on a petal graph, the first thing I always want to do is find the location of my first petal. And I do that by taking the value of a, which is the coefficient of the cosine function, and then replace it with r. So I have my equation, 5 cosine 3 theta equals r, but replace r with 5. And then from here I just solve this as a trig equation, but only for the first value. I don't need to solve it for all of them like I did in the last chapter. So I'm going to divide both sides by 5. And then I want to know where is cosine equal to 1. And so I know that cosine is equal to 1 at 0. So cosine equals 1 at 0, so I don't need that part anymore. And so I would just make it equal to 0. And then divide both sides by 3. And so then I would get theta is equal to 0 divided by 3, which is 0. So then my first petal is a length of 5, and it is located at 0. So let's go ahead and draw that in. So again, there would be concentric circles, but I don't need to draw those, right? If I don't have polar paper, I can kind of just do, something working with the x and y axes. Similar kind of notation, and then just kind of scaling out at each of those radial lines. So theta equals 0 is the radial line, and then I'm going a distance of r is equal to 5. So then I want to find the number of petals that I have, and then also my spacing. So to find my spacing, I want to take a look at b, and so b is that coefficient of theta. So then I know b is equal to 3. And then 3 is an odd number. So to find the petals, I would multiply by 2, right? So there would be 6 petals, but because it's odd, we are going to only see 3 petals because the other 3 petals are on top of the first 3, right? So they trace over the existing first 3. And then, so that means we're going to graph 3 petals between 0 and 2 pi. So that spacing would be 2 pi over 3. Okay, so let me get some common denominators here. I'm going to give myself a little room. Let me erase that. Okay, so this will be 3 pi over 3 here, 6 pi over 3, so halfway in between would be 4.5 pi over 3 and 1.5 pi over 3. So I need to go 2 pi over 3 from 0, so that would be somewhere over here. And I'm going to label that, so 2 pi over 3. And then I know my radius was 5, so I'm going to go out 5 units along that radial line. There's the tip of the petal. And then now I need to add another 2 pi over 3 to that, so I'm going to add 2 pi over 3. So that would put me at 4 pi over 3. So again, I want to mark 4 pi over 3. So somewhere over here. And then a radius of 5, so count out 5 units. Okay, and then for my start and my stop, so this one's a lot easier to work with because here my first petal that I found had theta equals 0, so I don't have to solve for it like I did on the sine one. So theta equals 0, that occurred at 5, so that is my start and my stop. So that would be right here, and then in a counterclockwise direction towards pi over 2, and there is my start and my stop. Okay. All right, let's do one more petal graph. So we're going to do just one more petal. Okay, so I'm going to do r is equal to 2 sine of, let's do 5 theta. Okay, so r equals 2 sine 5 theta. So I always want to find that location of that first petal that has a radius equal to the coefficient. So my equation is 2 sine 5 theta. But then I'm going to take that value of r, which is 2, and substitute it in. So then this would be equal to 2. And then solve that equation. So I'm going to divide both sides by 2. So sine of 5 theta is 2 divided by 2, which is 1. Okay. And then from there, I want to know where does sine equal 1, right? So where does sine equal 1? And as soon as I figure that out, I don't need that sine anymore or that 1. So sine is equal to 1 at pi over 2. And then normally I would divide both sides by 5, but in this case, I'm going to multiply by 1/5 so I can kind of keep that fraction format. And so then theta is equal to pi divided by 10. Okay. So then that first petal occurred when the radius was 2, and then that was at pi over 10. Okay. All right, so let's go ahead and graph that. So I'm going to go ahead and mark this as 10 pi over 10 here, 5 pi over 10, 15 pi over 10, and then that would be 0. So pi over 10 would be somewhere right around there. And then I have a radius of 2, so I'm going to just count out 2. And then draw in my first petal. Okay. All right, and then let's figure out the spacing. Okay, so for the spacing, I know that I have to find b. So here, b is always that coefficient of theta. And so b is equal to 5. Okay, and so then that is an odd number. So b equals 5, 5 being odd. And so then that means that I'm going to have, typically I would just do 5 times 2, which is 10. And so then because it's odd, though, I'm only going to see 5 of the petals. If it was even, I would see all 10, but I'm only going to see 5 of them. And so then I need to find my spacing. So I'm going to graph 5 between 0 and 2 pi. So that would be at 2 pi over 5. But I want to get that common denominator of 10. So I'm going to multiply top and bottom by 2 just to help me with the addition of that. And so then my spacing is actually going to be 4 pi over 10. Okay? All right, so then I'm going to add 4 pi over 10 to each of these values to find the next one. So when I add 4 pi over 10, that will put me at 5 pi over 10. So that would be right up there. So at the quadrantal there. Okay. All right, and then do the same thing again. So then now I'm going to add another 4 pi over 10, which will put me at 9 pi over 10, so just barely before I get to the second quadrantal. And then I'm going to go out 2. So there we go. And then we're going to add another 4 pi over 10. So that will put me at 14 pi over 10, so just before I get to the 15 pi over 10, and then out 2. And then the very last one here, so my scale I know is a little bad, but that's all right. So then when I add another, oops, let me label that. So that was 9 plus 4, so that put me at 13. Okay, so then my next one, I'm going to add another 4 pi over 10, so 13 plus 4, so that would put me at 17 pi over 10, so somewhere over here, and then out 2 units. Okay. All right, so definitely not very symmetrical, but that's okay. I got everything labeled, and so because of my labeling, it doesn't matter if it's to scale or not. All right, so then the last thing I want to do is figure out my start and my stop. So for my start and my stop, which is going to be at the same place, I'm going to figure out what's going to happen at theta equals 0. So I have to actually solve this one, unfortunately, right? Because my first petal was not at 0, but at pi over 10. So then that means I have to solve for it. So I'm going to let theta equal 0, and I'm going to do that in my original equation. So I have r equals 2. And then sine of 5 theta, but replace theta with 0. So that would give me 2 times the sine of 5 times 0. And I know that sine at theta equals 0 is 0, so 2 times 0. So that would be from the pole. So I'm going to go to the pole here. And then from there, go in a counterclockwise direction. And then towards pi over 2, which was my first petal. Okay, so there's 3 practice problems for petals, and the next video will be on cardioids and limosons.